the graph below shows the straight line PQ. So we have the line PQ on the graph. Now let's look at what they're asking us to find. It says find the gradient of the line PQ. Now let's go back to the graph. Now what we can do, we can select any 2 points. So I'm going to select these 2 points and I'm going to form a triangle like that. And then I am going to count up the squares on the base of the triangle. So that's 1, 2, 3. And I'm going to count up the squares that makes up the height. So 1, 2, 3, 4, 5, 6. Now, if you recall that the gradient is rise over run. So this is rise, which is equal to 6 squares, and the run, which is equal to 3 squares. So therefore, if I go back down to the question, so gradient is equal to rise over run, which is equal to 6 over 3, and that's equal to 2. So a gradient is equal to 2. Right? So that is the easiest way to find the gradient. The next way you could find the gradient, let's go back up here. We could, using the same points we selected right here. So this point right here is 0, 1. And this point right here is 3, 7. So what we could do now is label them x1, y1, and this is x2, y2. So the gradient now would be y2 minus y1 over x2 minus x1. So if we look at these now, we're going to have 7 minus 1, that's 6, over 3 minus 0, that's 3, and we get 2. Right? So this method, rise over run, once we have the grid, we can use the rise over run, and it is the easiest method. You still get your full marks. Now, part 2, it says, write down the equation of the line through PQ in the form y equal mx plus c. So m is the same thing as the gradient in this case, so we need to find c. Right? C is the y-intercept, so we're going to go back to our graph, and the point right here is the y-intercept, that is 1. So recall that the y-intercept is where the line cuts the y-axis, right? So if we go down here now, c is equal to 1, so we get y is equal to 2x plus 1. Let's look at the next part of the question. Two functions f and g are defined as, so we have f of x is equal to x squared minus 1 and g of x is equal to 3x plus 2. So here it says find g of negative 6. So all we're going to do, we're going to substitute 6 for x in g of x. So this is going to be 3 times negative 6 plus 2. Now 3 times negative 6, that is going to give us negative 18, and then plus 2, so that is going to give us negative 16. Right? Now in part 2, it says find g inverse. Now, what we're going to do to find g inverse, we're going to replace the g of x with y, so we're going to say y is equal to 3x plus 2. Now we're going to interchange the x and the y. So we're getting x is equal to 3y plus 2. Then we're going to transpose for y. So if I subtract 2 from both sides, I'm going to get x minus 2 is equal to 3y. Then divide both sides by 3. I get x minus 2 divided by 3 is equal to y. Therefore, g inverse of x is equal to x minus 2 over 3. Let's look at the next question. Now here it says, show that f of g of x is equal to 3, open bracket, 3x plus 1, close bracket, x plus 1, all brackets. Now let us go back up here and look what is g of x again. Now g of x is 3x plus 2, and f of x is x squared minus 1. So let's go down here and write it down. So we have g of x is equal to 3x plus 2, and f of x is equal to x squared minus 1. Now we're finding f of g of x. Now f of g of x is the same thing as f open bracket g of x. That is, wherever we see x in f of x, we're going to replace it with g of x. Now f of x is x squared minus 1. So I'm going to replace the x with g. So g squared minus 1. Now we know what is g of x is. We know what g of x is. So we're going to get 3x plus 2 all squared minus 1. Now let's expand. Let's expand the bracket. So this is going to be 9x squared plus 12x plus 4 minus 1. Right? Now we can subtract 1 from the 4 because they are like terms. So we get 9x squared plus 12x plus 3. So this is what we are left with. Now all we need to do, we need to show the examiner that this is equal to this. Now notice that there's a 3 on the outside right here. There's a 3 right here. So what I can do, I can factor out 3 from this quadratic expression. So let's factor out 3. So we're going to get 3 open bracket, and we're going to get 3x squared plus 4x plus 1. So we now need to show that whatever is in the bracket, that's this here, whatever is in the bracket, it's equal to 3x plus 1, x plus 1. Now, once we factorize the quadratic expression in the bracket, we will arrive at the answer. So let's go up here and factorize the quadratic expression. So we have 3x squared plus 4x plus 1. Now, A is equal to 3, B is equal to 4, and C is equal to 1. A times C is equal to 3, and we need to find factors of 3, that when we multiply we get 3, and when we add we get 4. So it is going to be 3 and 1. I can factorize this by grouping, by replacing the 4x with 3x plus 1x. So this is going to be 3x squared plus 3x plus x plus 1. Now I can factorize by grouping. So let's factorize by grouping. So this is going to be 3x open close bracket. I'm going to be left with x plus 1 and then plus x plus 1. You can put that in bracket. So what is common to both of them is x plus 1, and we are left with 3x plus 1. So notice that these two factors are the same factors we have here. We have 3x plus 1 and we have x plus 1. So therefore this is equal to 3 times 3x plus 1 times x plus 1. So all this is testing you for is how well you can factorize the quadratic expression. Another way we could approach this is to expand the expression here and then compare it to this. Once they are equal, we could go ahead and state that hence f of g of x is equal to 3 times 3x plus 1 times x plus 1. Right? Let's move on to part B of the question. It says hence solve the equation f of g of x is equal to 0. Now notice that they say hence. Right? So therefore, we're going to use the result in the previous question. So therefore, in order to solve f of g of x equal to 0, I am going to set it to 0. So therefore, 3